is simply that this is equal to the change again in fx due to the delta y, which is equal to fx y times the delta y. So to write that out just a little more explicitly, I'm going to say this is fx y evaluated at x, which is still our variable of integration, y naught times delta y, then integrated with respect to x, and then plus the integral from y naught to y naught plus delta y of the change in fy due to delta x. Using this idea, that gives us fyx evaluated at y, which is again our variable of integration, and at x naught, and that'll be times delta x dy. Now another side note, that f of x, fxy of x y naught delta y is approximately equal to the integral with respect to y of fxy of xy dy, and bad looking y, I'll have to fix that in a minute, and that integral going from y naught to y naught plus delta y. Also, fyx delta x is approximately equal to the integral of fyx of xy with respect to x going from x naught to x naught plus delta x. And with these two facts, we can then rewrite these as double integrals. Now I'm doing a little bit of hand waving here, but not too awful much. In the limit, as delta x and delta y approach 0, of course this whole thing approaches 0, but this can be written as negative the integral from x naught to x naught plus delta x of the integral from y naught to y naught plus delta y of fxy of xy dy dx, because of course this integral, if we have small enough y, is close to this integral. And then that would be plus the integral from x naught to x naught plus delta x excuse the slight gap, I started to miswrite this integral. This is of course the integral from y to y naught plus delta y of fyx, etc. And the fyx is approximately equal to this integral. So I'm going to say that's the integral then from y naught to y naught plus delta y of the integral from x naught to x naught plus delta x of fyx of xy dx dy. Now the thing that's remarkable here is not so much that this integral has to equal 0 because, of course, we began with an integral around a path, but that we have an area integral. So this is an integral over a plane region, i.e. an area integral. We started with a line integral. So somehow we integrate a quantity over the boundary and that gives us an integral of a related quantity over the entire area enclosed by that boundary. This is a big, profound idea. One of the central ideas in the chapter, and we'll encounter it again once we've developed a little bit of machinery, and by then we'll have had time to absorb the whole idea of converting this path integral to an area integral.